Welcome to the Advanced Manufacturing Systems Lab at HCC. In spite of the pandemic, we are conducting face-to-face classes for the training that you will need in an automation technician job or a manufacturing technologist. Here you'll find some of the same equipment that you've seen if you've taken technical courses at the local area tech schools. But I'm going to take you on a short tour just to familiarize you with some of that. This hands-on training system allows you to use programmable logic controllers. They operate an electric motor, a pneumatic cylinder, and material handlers as well. The Allen Bradley PLC isn't a real industry standard system, so you're learning what you need for the jobs. We can tweak this system to change pressure, force, and speed to see how the system responds. Speaking of force and speed, we see now some equipment that we use to learn about the transmission of power. There are shafts, belts, and gears, and chains to test rotational force and speed. These are controls that are used in industry for the conveyance of material, and even on vehicular systems. In fact, you'll find them in robots. To introduce you to our robots, in fact, I'm taking you now to the Advanced Technology Center to introduce you to Professor Greg Betts.
Here in our robotics lab, we start our students with these tabletop-sized robots. They teach the students about degrees of freedoms, work envelope, and different types of end effectors. Once they're finished with these, we move on to the industrial robots like you see behind me. Here we have some of our ABB robots as well as our assembly line, which introduce students how mechanical, electrical, pneumatics, PLCs, and robotics all integrate together to be able to build a desired product.
The Electrical Engineering Technology program at Hagerstown Community College prepares students to troubleshoot, design, manufacture, test complicated equipment like robots, electronic communications, electrical machines. All of them are part of our curriculum. The Electrical Engineering Technology program also offers a basic electronics technician certificate. This certificate allows the students to prepare for an entry-level job in the manufacturing industry. The students can learn the fundamentals of electricity with advanced and state-of-the-art equipment like the one that we have here. So this equipment is part of the linear motors course and process control with robotics. This is part of the printed circuit board lab. The student designs a printed circuit and they use this machine to generate a printed circuit board. The students learn about electronic communications. They learn about AM, FM, cellular, microwave, and satellite communication. So the Digital Instrumentation and Process Control program offers our students a broad range of jobs. Like for example, the food industry, the energy and utilities industries, manufacturing facilities, all of them are targeted by our program. They can learn about temperature sensors, about flow control sensors, about level control sensors, pressure sensors, and they can, all of them are very important in industrial processes. The students can also learn about temperature control processes like operating with semiconductor wafers. Here you can see that we have a small oven and an industrial oven here where they can operate and control steam and control temperature of the steam and the oxidation process in a semiconductor wafer. We do have a PLC, which is an industrial computer that is going to control the process in a conveyor belt. This is a conveyor belt with, where we are going to have proximity sensors. We're going to have optical sensors, a compressor, a motor, and everything will be controlled by a program that the student is going to operate in this computer.
My name is Dr. Olu Babaduro. I'm a faculty member and the program coordinator here at Hagerstown Community College for the Mechanical Engineering Technology Division. And one of the aspects you see in our everyday world is advancement of technology. And one of those attributes can be attributed to materials or material selection. One of the courses that I actually teach here at HCC within the Mechanical Engineering Technology division is Strength of Materials. And that is nothing more than a branch of engineering that allows us to study the behavior of solid objects subjected to a stress or strain. For instance, we have what we call a universal testing machine here that allows us to do tensile testing, compression, and bending. In this case, we have a tensile setup whereby we have a dog bone specimen made out of polymer. And we want to be able to understand when we induce a load, which will give us the stress, how does that material respond geometrically in the strain component? So therefore, understanding the relationship between stress and strain graphically allows us to extract information about this material, such as ductility. We have the yield point, we have the ultimate strength, and the point at which it breaks. That information and much more allows us, when we're building a structural application, allows us to judiciously choose what kind of material that can actually be used for this application in terms of sustainability. Technologists are really the link or the glue between engineers, fabricators, and an assembly team. The idea that fluid can be either liquid or gas gives us an opportunity to be able to build systems, either hydraulic or pneumatic, around that definition. In this case, in this setup right here, we have a pneumatic system whereby we have a conditioning unit whereby compressed air comes into this conditioning unit. And the whole idea for this particular setup really is students to understand how you can use a pilot operated valve system to be able to actuate or control a piston. Now, in this case, as you can see, this setup is being bypassed. So if I were to initiate this operation, as you can see, there's really no control over the extension or the traction of this particular piston. Now, if I were to change this operation around, using this as a medium as to how we're using airflow as a mechanical force in the midst of a spool system, now I can extend the piston and I can also retract it. And students are typically responsible for understanding how each individual component of the system work and how it works together as an assembly. Here we have, this circuit is in series, meaning that these pistons operate in a series mechanism. So we have here, to my bottom right, we have a pump that is actually flowing through this system, and we have a bi-control valve that allows us to move the piston or extend the piston and retract the piston at the same time. But if you notice that by these pistons being in series, they do not travel at the same speed. So the job of the student really is to be able to critically think through the process and understand why these pistons, when they're in series, they do not travel at the same speed. Another branch of our Mechanical Engineering Technology course is machine design that we talk about here at Hagerstown Community College. And this particular course utilizes all the concepts we learned from our first semester, second semester, third semester, and part of our fourth semester. For this particular project, which is a capstone project whereby we converted a gasoline-operated go-kart into a solar-powered vehicle. So the idea really was to use a lot of the concepts from strength of materials, understanding how welding and CNC, how all those components play a role in building this particular structure. So up top here we have our solar panel, which actually captures the array of light, and it charges the battery in the back that we see here. And underneath, of course, it has an electric motor that is being turned by a chain. So the students really designed this and built it on their own. And one of the advantages of this particular project is it allows to foster teamwork and also be able to hone in on some of the concepts that they've learned throughout the semesters to be able to build a product which we see right now.